Welcome to Specialized Space, where we dive deep into the wonders of the universe and explore everything space-related, from mind-blowing discoveries to the latest in space technology. Prepare yourself for an incredible space spectacle on the horizon. A vibrant pink giant star, found on the border of our own galaxy, is transmitting peculiar messages throughout the universe. Scientists, using the James Webb Space Telescope, have uncovered unsettling discoveries regarding this giant of a celestial object. Renowned astrophysicist Brian Cox issued a chilling warning, posing the question to us: are we on the cusp of seeing a cataclysmic supernova explosion that would forever change our night sky? We're about to get into the nitty-gritty. In space's vastness, where stars are born, live, and eventually reach their ultimate demise in an inspiring spectacle, stands one star that has been of late a focus and challenge for astronomers and the masses. That star super is Betelgeuse, a dark red supergiant of humongous size and age, residing in the center of the constellation Orion. While its characteristic reddish hue and changing brightness have been a source of concern to observers for a long time, recent developments have increased interest in this star giant. As we look at the nature of Betelgeuse, we stand at the doorstep of an undoubtedly titanic event in the celebrity's life cycle. But what are these changes in Betelgeuse supposed to mean? Are we witnessing the onset of an unimaginably stupendous cosmic spectacle? Betelgeuse is approximately 764 times the size of our Sun, a giant star of colossal proportions, almost beyond human comprehension. Imagine a celeb of such magnitude that if it were to replace our Sun, its surface could extend past the orbit of Mars, its star body encompassing Mercury, Venus, Earth, and Mars. This remarkable size currently not only features Betelgeuse's physical features but also mirrors its stage within the stellar life cycle. As a purple supergiant, Betelgeuse is at the end of its life, characterized by the process of growth and cooling following a lifetime of burning hydrogen into helium in its core. Despite being remarkably young in human years, approximately 8 to 8.5 million years of age, Betelgeuse's pink supergiant status is the culmination of tens of thousands of years of stellar evolution, a transition from a hot blue star to the red giant we see today. Don't forget to press that subscribe button and be part of the Specialized Space Network. Stay informed on everything area, and let's explore the universe together. Betelgeuse's red-hued alternative color is based on its cooler surface temperature relative to stars like our Sun. While the Sun's surface temperature is about 5,500 Kelvin, Betelgeuse's less vibrant surface suggests temperatures of some 3,000 to several 500 Kelvin, emitting balmy at wavelengths that give it a red color. Such color is not just surface level but gives hints on the physical condition of the star, as well as processes within its enormous gaseous bulk. Adding to the mystery of Betelgeuse is its former color alternate. Ancient Chinese and Roman writings propound it as a yellow celebrity around 2,000 years ago, although Arabic scholars had originally described it as crimson way back in the 9th century. This coloration shift over time is full of hints regarding the evolutionary history of the big name. The volatility of Betelgeuse's brightness is similarly fascinating. As a semi-regular variable celebrity, its light occasionally grows and diminishes in a dance of brightness in a function of luminosity, with a 400-day period and a more extended period of approximately 5 years. These cycles have been noted keeping in mind since 1836 by Sir John Herschel and perhaps even before that in Aboriginal folklore. But what adds to the suspense of Betelgeuse is not only its variability of brightness, but its unpredictability. Differing from most stars that adhere to a steadfast pattern, Betelgeuse sometimes deviates from its cadenced brightening and fading, indicating intricate and much less mundane processes in its massive body. In the latest groundbreaking breakthrough, Betelgeuse startled astronomers and celestial observers around the globe with a sudden and striking change in its appearance. Infamously dubbed the Great Dimming, at the end of 2019, the purple supergiant star Betelgeuse, one of the brightest stars in the night sky and a well-known feature of the Orion constellation, started to dim mysteriously. The decline of the giant star into so remarked that it started to lose its luminosity at a mean rate of 0.1 magnitudes per day, bottoming out in February 2020. Betelgeuse, usually observable to the naked eye even in urban light pollution, have become quite dimmer, a challenge even amateur astronomers must face. There may, however, be an assignment while trying to monitor Betelgeuse's performance: the time paradox. When we view a star like Betelgeuse, we are not seeing it because it is in the gift, but because it came to be in the beyond. Due to the amount of time it takes light to reach us, approximately 725 mild years away, the mild we see today left the big name close to 7 centuries ago. That latency complicates predictability and reveals unexpected changes in a celeb's conduct because we are observing its past effectively. Andrea Dupree, co-director of Harvard's and Smithsonian's Center for Astrophysics, along with her collaborators, closely observed the unfolding star drama with the Hubble Space Telescope. They observed the giant superstar as part of a 3-12 months examined to trace variations in Betelgeuse's outer ambience. These observations provided accurate insight into the dynamics of a variable celebrity similar to Betelgeuse, which regularly swells and shrinks, resulting in changes in brightness. Hubble's ultraviolet sensitivity enabled scientists to explore the layers above the celebrity's surface, warmed partly by the celebrity's turbulent convection cells. Further examination of Hubble spectra received at unusual points in 2019 and 2020 helped to degree fabric movement within the outer atmosphere of Betelgeuse, specifically targeting magnesium traces in accordance with megastar atmospheric circumstances. What they discovered, there was fabric moving at 200,000 mph from the surface of the celebrity to outer environments. This hot, dense material subsequently expanded hundreds of thousands of miles from Betelgeuse and developed into the precursor to the dirt cloud that marked the megastar's dimming. Dupree and colleagues estimated that this amount of material is about twice the normal amount from Betelgeuse's southern hemisphere that became misplaced during the 3 months of the outburst. This loss of mass manifested in enormous, most of all considering that Betelgeuse, like all stars, gradually loses mass, though at a price a considerable distance greater than our sun's. The scale of this ejection of mass and subsequent fainting raised a question among astronomers of whether or not this event would be the precursor to a supernova explosion. The comparative proximity of Betelgeuse, some 725 mild years from Earth, contributes to the intrigue, since the nature of explosion would be discernible on Earth and offer a rare chance to behold a supernova up close. Yet there remains the question: what does this dimming phenomenon portend for the future of Betelgeuse? Is it a harbinger of an imminent supernova, or seemingly an isolated event in the megastar's long-lived existence? Several theories were posited to offer an explanation for this sudden trade. One universal principle proposed a stage in the supernova explosion process, one that was on the rise in popularity because of the not unfamiliar notion that Betelgeuse is nearing its demise. Another favorite principle stated the potential of dust, indisputably from Betelgeuse itself, obstructing our view. Red supergiants like Betelgeuse do lose material, and it was recommended that the material could produce a dense dirt cloud, leading to a dimming effect when located from Earth. Another cause that was in question was fluctuations in the big name's photosphere, its visible floor layer, which could impact its apparent brightness. In order to dispel this mystery, an investigation, the application of several observational methods, became ordered. Spectroscopic observation found the decrease in Betelgeuse's intense heat, which means the dimming can be caused by a monstrous darkish blotch on the star's surface. Supporting this proposal became the knowledge that the temperature of Betelgeuse declined by utilizing no less than 70 Kelvin over the period of dimming, which means very significant changes in the floor. Lastly, the step forward that this bizarre phenomenon offered was given by the Hubble Space Telescope, the watchful eye of humanity in the vastness of space. The observations of Hubble were that Betelgeuse's dimming was quite likely caused by a huge ejection of hot material into space. This material formed a cloud of dirt which obscured a portion of the star's floor, cutting down on the amount of light reaching us from Betelgeuse. The cloud of dust developed into believed to have been created from first-rate hot plasma that had been driven out by a giant convection cell on the huge name of the star. Cooling, it condensed straight into dust grains, developing a cloud that enveloped gentle from maybe a quarter of the celebrity's surface. Ultraviolet light spectroscopic observations with Hubble, which began in January 2019, played a crucial part in completing the timeline that led to Betelgeuse's fading. These observations indicated soiled heated material carrying through the celebrity's surroundings over the months prior to the dimming. December of 2019 witnessed different Earth-based telescopes pick up the star fading in brightness, specifically in its southern hemisphere. The material, first brighter than the megastar's normal light, later contributed to the formation of a darkish cloud as it moved outward and cooled down. The theory posited that this outward-moving material